The next algorithm is sequential, and as its name suggests, in sequential mode, the rule engine executes rule instances in their order of appearance, or sequentially. With the sequential execution mode, the application passes the objects through rule set parameters. For each match that the rule engine detects between an object and a rule condition, a rule instance is created and immediately fired. It's not stored anywhere. When a rule instance is fired, the corresponding rule action is executed. If the action modified an object value in some way, the rules that fire after this update will take that modification into account, but rules that were already fired are not reevaluated for new matches. Because of its sequential or systematic nature, this type of execution mode is good for validation or compliance applications. Because the rules are executed in sequential order, there's no rule chaining and no need for an agenda. Sequential works best with rule set parameters as input. If your application has a large number of rules with randomly ordered tests and passes data through rule set parameters, you should consider using the sequential mode. This slide goes over the steps that the rule engine follows when running in RetePlus mode. The client application passes objects to the rule engine. Generally, with the RetePlus algorithm, instead of using rule set parameters to pass the objects are inserted into working memory, which is simply a logical space to store objects during rule execution. As a first step, the rule engine begins the pattern matching process by testing every condition from every rule in the rule set against each of the objects in working memory. Every time a match is found, a rule instance is created and put into the agenda. The agenda is also a logical space where rule instances are stored until they're fired or executed. If a rule condition matches several objects, the agenda can have several rule instances for the same rule. So every match between a rule and an object creates an instance that gets stored in the agenda. The next step, Step 2, the rule engine then decides which rule instance in the agenda to fire. After a rule instance is fired, it's removed from the agenda, and the corresponding rule action is executed. In Step 3, you see that the executed action could affect the objects that were passed from the application. So as a side effect of rule execution, the action might modify existing objects, create new objects, or delete objects. Depending on what update was made, the rule engine might be triggered to repeat the pattern matching process and reevaluate the rules against the objects to again see if new rule instances are created. This is called rule chaining, where execution of one rule can change an object so that that object then matches another rule. For rule chaining to work, though, you need to make sure that when you're defining your objects on the BOM, that you've selected the Update Object State property, and this is what notifies the rule engine when an object state has been updated. RedTape works well with most types of rules. Keep in mind its main characteristics, that it uses working memory, the agenda, and that it can include rule chaining. Here are some additional guidelines to help you identify which types of applications are best suited to using RetePlus mode. Going back to the RetePlus algorithm, we previously talked about how during the pattern matching process, when a rule condition matches an object in working memory, a rule instance is placed into the agenda. The agenda then orders the rule instances and selects which one to fire first based on refraction, priority, and recency principles. The principle of refraction prevents loops. Priority and recency are used to resolve conflicts when several rule instances are candidates for firing at the same time. These principles are described next. During the pattern matching process with RetePlus, rule instances are created when an object matches the rule condition, and those rule instances are put in the agenda. After a rule instance fires, it can't be put back in the agenda if the matched objects weren't changed, or if the matched objects were changed, but in a way that the condition is still true, which would mean it's not a new match, it's the same match that already fired. For example, if rule 1 matches an object called object 1, the rule instance rule 1 object 1 is placed in the agenda. With refraction, after the rule 1 object 1 rule instance fires, this rule instance is removed from the agenda. If rule 1 did not modify object 1, then the rule engine will not reinsert rule 1 in the agenda, even though rule 1 and object 1 still match. So what happens if both rule instances have the same priority? Well, then the principle of recency would determine that the most recent rule instance for the matched rule and object fires first. So recency uses last in, first out. For example, as shown here, the two rules, rule 2 and rule 3, both match object 2. So the two rule instances are placed into the agenda. If the rule instance for rule 2 is created after the rule 3 rule instance, well, rule 2 will fire first. Last in, first out. Now what if firing the rule 2 object 2 rule instance modifies object 1 so that now object 1 also matches rule 2? Well, a new rule instance called rule 2 object 1 will be placed in the agenda. But since this new rule instance becomes the most recent match, then this rule instance, rule 2 object 1, is fired before rule 3 object 2, even though rule 3 object 2 was already in the agenda. To help you determine which execution mode to use or is most appropriate for your application, you can use the information listed in this table and ask yourself some questions such as, what type of application do your rules implement? What type of objects do the rules use? What's the effect of rule actions? What sort of tests do you find in rule conditions? What priorities have you set on the rules? These types of questions can help you determine whether or not you can use the default FastPath execution mode. This table can also be used to help you identify which execution modes are best suited for certain application types. For example, compliance and validation applications work well with FastPath or sequential execution mode. For computation or correlation application types, either RETE+ or FastPath are suggested, depending on whether inference is necessary. Whereas for stateful session type applications, RETE+ is the execution mode to use. To better understand how the rule engine behaves in the RETE+ mode, let's take a look at an example called trucks and drivers. The next slides illustrate the interaction between the rule engine, the working memory, and the agenda. You'll also see how rule chaining can be triggered when rules modify the state of an object. For this example, the rule project contains two rules, change tire and assign driver. Take a minute to read the conditions for these rules. Now these rules evaluate objects in working memory that are based on two BOM classes, the truck class and the driver class. In the BOM, both of these classes were defined with the update object state option selected. So that means if these objects are modified during rule execution, the rule engine will be notified and will re-perform the pattern matching process against these updated objects. As a first step, the rule engine loads the rule set, which in this case contains the two rules. From the client application, you see two trucks, a tire, and three drivers as input to the rule engine, and these objects are inserted into the working memory. The rule engine starts the pattern matching process by testing each rule condition from the two rules against each object in working memory. When the rule engine evaluates the conditions in the change tire rule, it finds a matching truck and an available tire in working memory. Because the rule condition tests true, an instance of the change tire rule is put into the agenda. Next, when the rule engine evaluates the assigned driver rule conditions, it finds 3 separate matches: the blue truck plus the driver with the blue hat, the blue truck plus the driver with the green hat, and the blue truck plus the driver with the red hat. Each of these matches create a rule instance that's put into the agenda. Now the rule engine selects one of the rule instances to execute. In this case, the change tire rule has the higher priority, so the change tire rule instance executes first. Immediately after executing the change tire rule instance, the objects in working memory are updated. As a side effect of this rule, a new truck object is now available to be assigned. Because these objects in working memory were updated, the rule engine was triggered to retest all the conditions of all the rules in the rule set against these updated objects, and it now finds new matches for the assigned driver rule. So the rule engine matches each driver to the newly available brown truck and creates 3 new rule instances of the assigned driver rule in the agenda. Based on the recency principle, where the last match fires first, the rule engine executes the most recent match, which is between the brown truck and the driver with the red hat. Immediately again, the working memory objects are updated and the rule engine is triggered to redo the pattern matching. This time, the assigned driver rule cannot be matched with the brown truck or the red hat driver. Their state has been updated and they are no longer available in working memory. As a result, all rule instances that used those objects are deleted from the agenda. Now, the rule engine executes the next most recent rule instance, which is the assigned driver rule with the blue truck and the driver with the green hat. Again, the working memory is updated, the rule engine is triggered to retest the rules, the blue truck is no longer available, so the remaining rule instances that used that truck must be deleted from the agenda. The rule engine can't make any more matches between the objects in working memory and the rules from the rule set, so the agenda is empty and rule execution is complete. So now you should be able to understand what to expect during rule execution with RETE+ mode. You have now completed this unit. Having completed the unit, you should be able to describe a rule engine, describe rule execution, and explain rule execution modes and execution principles.